This video talks about the um, Pythagorean theorem, but talks about applying the Pythagorean theorem. Hopefully you've seen the video that talks about how we know the Pythagorean theorem is true. Now we're going to talk about how we can actually solve problems using the Pythagorean theorem. One of the most common applications of the Pythagorean theorem is one I've seen a lot. I used to check the reinforcing steel inside the concrete forms, and I would see people doing what you're seeing here. It's called squaring up the forms. They would actually measure the diagonals of the forms using the Pythagorean theorem, and I wanted to show you an example of that. So I've got a drawing of a house. It's kind of scaled down, but we can use it to figure out how you would make sure that the corners are square. So if you measure this diagonal, it tells you that this is square. If you measure this diagonal, it tells you that this corner is square. And you could measure this diagonal to check that this corner is square. Typically, you would do that all at once. I've seen people with 4 or 5 different 50-foot tape measures measuring all of the diagonals on a house. We're just going to do the one calculation because they're all basically going to be the same. So I am looking at this triangle where I have A. I need to find B. And my hypotenuse, of course, is going to be C. We'll figure that out later. Got the issue here that I have fractions which are not pleasant and not easily done on the calculator. I shouldn't say that. It's very easy to do them on the calculator, but it's confusing for some people. So I'm going to take the first, the A value, and change that 27 feet 8 3/4 inches. In my calculator, I'm going to put in the 3/4 as 3 divided by 4, and that gives us the 0.75, which we're used to. Then I add the 8. That gives me 8.75 inches. If you have 36 inches, everyone pretty well knows that's 3 feet because there's 3 12s in 36. What you're doing is dividing 36 by 12. This is kind of confusing, but we're still going to divide by 12. I'm going to take my 8.75, divide by 12. It will be a decimal because it's less than 1, but then we knew that. And before I get any further, I'm going to store that because I want to do something else. I want to look at the end product. Ultimately, when I measure the wall, the tapes that I'm going to use are graduated in 1/16 of an inch. And don't know if you saw it in the video, but typically the crews will use plumb bobs, and they'll wrap the string around the tape. The string for the plumb bob is actually about 1/16 of an inch wide. There's not really any point in measuring or calculating this to the nearest 32nd of an inch. So my ultimate answer is going to be in 1/16 of an inch. And I'll need that because the tape measures do not have decimal feet. So I want to know how many decimal places I need for 1/16 of an inch. So I take 1 divided by 16, and I get 0.0625. So I know I need 4 decimal places. But when I'm rounding, I don't want to round too far. So I'm going to have 5. I need at least 5. I'm going to record 6 decimal places, just to make sure that I get enough accuracy. So it's kind of a complicated thing, but anyway, now that I know I need 4 decimal places, I'm actually going to use 6 to avoid rounding errors. I'm going to recall my number here, which was the decimal number of feet, 8.75 divided by 12. I'm going to add that to the 27. Now I've got 27.7291, and I'm going to put 67. 27.729167. So I'm rounding off to 6 decimal places. If I look at my 7th decimal place, it's a 6. That's greater than 5. So I round my 6th decimal place up to 7 instead of 6. Same thing now with my other numbers, 38 and 5 5/8 inches. So I'm going to take my 5/8. Oops. I forgot to save. My number. So I'm going to do Control C, Control V. Put the number back up on the screen, and now I'm going to clear my memory. And I'm going to store that number in memory. Because I wrote down enough decimal places, but I want to use as many as I can. Now I'm going to take my 38, 5 5/8 inches. So 5 divided by 8 plus 5 gives me the number of inches, divided by 12 gives me the number of feet, and I add my 38. So I get 38.46875. Hopefully I remembered that right. Yes. Ultimately, though, that's not part of my triangle. I need that, though, because when I have a rectangle, I've cut this into 2 rectangles. This side is also 22 feet, 1 7/8 inches. So I'm going to take this number and subtract 22 and 1 7/8 inches. It's going to be a little more complicated. I'm actually going to use my parentheses now. So I'm going to subtract. Then I'll go to my parentheses, and I will do 7/8 plus 1. And I'm actually going to start a second set of parentheses. 7 divided by 8 plus 1. I'm going to close those parentheses. So I have 1.875 inches. I divide by 12. That's going to give me the number of feet. And then I am going to add 22. And I close the parentheses again. So I'm doing my 38.46875 minus 22.15625. Now I push my equal sign. Having closed my parentheses, I've got the value of the side that's given. When I push my equals, I do my subtraction, 16.3125. So I have this side is actually 16.3125. And then as a result, my b is equal to 16.3125. So now I've got my two sides. I have my two sides in the calculator. And I'm going to go ahead and work with them in the calculator. So I was very careful to write down enough significant figures, enough decimal places. I don't really need to at this point because I have everything in the calculator. So I'm going to square b. This is my b that I have on the calculator now. And this button here where I have an x with a 2 above it, exponent of 2, that squares 16.3125. Now I need to add a squared, and a squared is in memory. So I do add, and I can do this because my calculator does PEMDAS. So it's going to square a before it adds it to b squared. I'm going to do memory recall now and push the squared button again. So I have 768.906684027777. And actually for this, so my C, and I'm going to write it up here, C equals 768.9066, 768.9066. Since I squared the number, I actually, and I'm going to take the square root of my answer. I'm going to take the square root of this. So I should really say C squared equals, forgot that, 668402, and then a bunch of sevens, 8402, 1, 2, 3, 4, 5, 6, 7, 8, 7. I'm actually going to need 12 instead of 6. I'm going to need 12 decimal places if I want to get enough accuracy. Because when I multiply two decimal numbers together, I end up with twice as many decimal places in my answer. So I am going to now I have C squared. To get C, I need to take the square root of C squared. And I have my square root over the x. I push that. I get 27.7291677. I did the wrong thing. You notice that's a number that we recognize. That was my C, or my B. I'm sorry, that was my A. So I took the square root after I squared it. I'm going to square it again. And I need to push equals. So that tells me I wrote down the wrong number because I wasn't thinking about how my calculator was working. I needed to push equals before it would do the addition. It's done the addition now. I get 1035. And 0043402. And And then I have a bunch of 7s. And again, I want 12 decimal places. If I'm going to re-enter it into the calculator, I need those 12 decimal places. If I weren't demonstrating this, I would actually just leave everything in the calculator. And now I take my square root, and I end up with C equals 32.171483. And I already forgot it, 32.171483. And I'm going to take a minute to monitor what I'm doing and think about my answer, just because there's so many mistakes you can make doing this. If I look at this, 27 and 16, C has to be the longest side. So it has to be more than 27.7. It has to be more than 16. My answer fits that criteria. If I look at the 3 sides of a triangle, if I think about how a triangle works, if I put the longest side down, then I look at the other 2 sides. If I were to fold those 2 sides out and lay them up against the long side, those 2 sides together would have to be longer than the longest side. So if I just look at A plus B, not A plus B, A squared plus B squared, A plus B has to be more than C. If I look at A plus B really quickly, I get 27 plus 16, 27.7 plus 16.3. I actually end up with 44. So I know C has to be less than 44. I need to be between 27 and 44. 32 is a pretty good, 32 is a very reasonable number. I'm happy with that. So now I just need to figure out what that is in inches and fractions. So I've got my 32, and I'll write that here. C equals 32 feet. We use the single apostrophe for feet. And so I've got my 32. I'm going to get rid of that. I'm going to subtract 32. And now I just have the decimal that I had written down. That's the decimal number of feet. If I have 5 feet and I want to know how many inches, I multiply 5 times 12, I get 60. If I have 0.171483 feet and I want to know how many inches, I multiply by 12. So I multiply by 12, and that tells me I have 2.0578 inches. So I'm going to write my 2, because I don't need to worry about that anymore. I've got my 2 inches. I'm going to get rid of that again. I'm going to take the inches out. Now I have decimal number of inches, a decimal number of inches. I'm going to multiply that by 2 to get halves. So I have 0.11 halves. That's not close enough. I'm going to multiply by 2 again to get fourths. I get 0.23 fourths. I still don't have a whole number. So if I try to round it off, it would be 0 fourths. And I want to be more accurate than that. So I multiply by a third 2, which gives me eighths. So I have 0.462 eighths. I'm going to multiply by 2 again, and I get 0.9248 sixteenths. I could multiply by 2 again to get 30 seconds, but as I said before, the 30 seconds, I can really only measure my distances to the nearest 16th of an inch. So I'm happy with this. I'm going to round it off and I will round that off to 1/16. So I will say 32 feet 2 1/16 inches is the distance I'm going to measure across that diagonal. And of course I could do the same thing with the other diagonals that I showed you, but no point in that. Let me know if you have questions, send me an email, or post a discussion question.